Lesson 7-5, compound events, and in this lesson you'll learn to find the probability of a compound event. Why is it important? Because you can use the tree diagrams to solve problems involving business, sports, and games. Let's take a look at the real-world application in archaeology. A group of college students are planning a trip to Virgin Islands National Park where they will study the Carib Indian relics and the remnants of the forts built by the Danes. The Carib Indians were the original occupants of the islands, but had died or left by the early 1600s. The Danes formally claimed the islands in 1666, and they remained under Danish control until 1917. Okay, so the group's advisor must plan how the group will get to the Virgin Islands. From their college, they will travel to Miami, Florida by car, bus, train, or plane. Then travel to St. Thomas of the Virgin Islands. They would take a plane or a ship. Suppose the advisor picks a mode of transportation at random. What is the probability that they will travel by car first and then fly? Okay, so to calculate this probability, you need to know all of the possible ways to get to St. Thomas. One method of finding this out is draw a tree diagram. The tree diagram below shows how to get from the college to Miami and then to St. Thomas. The last column details the possible combination or outcomes of the transportation. So these are the uh, things that you need to, they are going to decide on. So from college, okay, from college, which is here, there you go. They can travel uh, to Miami by car, bus, train, or plane. And from Miami, they can travel, okay, if they travel by car, they can travel by ship to St. Thomas or a plane to St. Thomas. If they travel by bus, they can travel by ship or plane, and so on and so forth, all the way down. And so from St. Thomas, okay, if you look at this carefully, from college, they can go car to Miami and then ship to St. Thomas. You have car ship as an outcome. Or travel by car to Miami and travel by plane, car plane as an outcome. Travel by bus to Miami and ship to St. Thomas, bus and plane. So and so on and so forth all the way down the line. So if you notice, there are 1, 2, 3, 4, 5, 6, 7, 8 possible ways, 8 possible outcomes for this to take place. Notice that the number of outcomes is the product of the number of ways to Miami, 4, and the number of ways to the Virgin Islands, 2. Okay, so with the tree diagram, you can also know that there are 4 ways to get to Miami, and there are 2 ways to get to St. Thomas. Multiply 4 times 2 will give you 8. Okay. Since the mode of transportation is chosen at random, you can assume that all combinations of travel are equally likely. Since there are 8 outcomes, the probability of traveling by car first and then flying is 1/8 or 0.125. Okay, why is it 1/8? Going back here. Oh, it's all gone again. So it says to travel by car and plane. That's it. And it's 1 out of 8 possible outcomes. Okay? The problem is an example of finding the probability of a compound event. Compound event, we defined this last year, but as as a review, compound event consists of 2 or more simple events. Choosing a car, plane, train, or bus for the first part of the trip is a simple event, and then selecting a plane for a ship for the second stage of the trip is another simple event. The selection of the mode of transportation of each part of the ship is what we call a compound event. So let's take a look at example number 1. Use a tree diagram for the application at the beginning of the lesson to answer each question. What is the probability that the group will take a ship to get to St. Thomas, and what is the probability that the group will travel by plane for both parts of a ship? Now, if you look at your book carefully and you look at your tree diagram, letter A answer, since 4 of the 8 outcomes involve taking a ship, the probability is 4/8 or 0.5. And since in letter B, probability will travel by plane for both parts of the ship. Since there's only one outcome out of 8 involving a plane for both parts of the trip, the probability is 1 over 8 or 0.125. Okay? Now let's refer back to the original lesson, the beginning of the lesson. Because one choice does not affect the others, we say that these are independent events. If the outcome of an event does not affect the outcome of another event, we say that these are dependent events. Again, a review from what we did last year in terms of probability of independent and dependent events. Okay, so an independent event means that an outcome of one event will not affect the outcome of another event, and a dependent event, okay, by the very word dependent, means that the outcome of the second event is dependent on the outcome of the first event. Okay, let's take a look at example number 2. Booker T. Washington High School is having its annual spring carnival. The 9th grade has decided to have a game booth. To win a small stuffed animal, a player will have to draw 2 marbles of the same color from the box containing 3 marbles, 1 red, 1 white, and 1 yellow. First, a marble is drawn, put back in the box, and then the second marble is drawn. What are the possible outcomes for letter A? What is the possibility of winning a game? Okay, so first, let's draw a tree diagram to see the possibilities of drawing 2 marbles of the same color. Okay, and let's take a look at this one. You have the first selection would be red, white, and blue. Red, white, and yellow, sorry. Okay, and then you draw a tree diagram. In the second selection, you will also get red, white, and yellow. And the third selection, not the third, sorry. The possible outcomes would be red, 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 white, red, yellow, white, red, white, 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 yellow, yellow, red, yellow, white, and yellow, yellow. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 possible outcomes. Okay, and if you notice, there are 3 possible. In the first event, there are 3 choices to choose from. Okay, and in the second selection, there are also 3. So therefore, you multiply those 2, you end up with 9 possible outcomes. But it's asking, not the number, okay, what are the possible outcomes? So when you say what are the possible outcomes, these are all the possible outcomes for letter A. There are 9 of them. Okay, in letter B, okay, it's asking for letter B, what is the probability of winning a game? First and foremost, when they put the marbles back into the bag, okay, it means that the second event will not depend on the first event because all the marbles are back in the bag. So this is an example of an independent event. Okay, so there are 3 ways out of 9 to draw the same color twice. The probability for each draw is equally likely, so the probability is 3 over 9. Okay, it's asking what is the probability of winning a game, meaning you win a game when you draw the same color, and these are the same colors right here: red, red, white, white, yellow, yellow. Okay, so there are 3 of them out of 9 possible outcomes. That's 3 out of 9, 1/3, or 0.3 bar notation on 3. Okay, and let's take a look at the last example. Okay, probability can also play an important role in determining the possible outcomes of a sporting event. The Rockets and the Knicks are going to play for the best of 2 out of 3 exhibition game series. What is the possible outcome of the series? Letter A. And letter B, assuming that the teams are equally matched, what is the probability that the series will end in 2 games? So let's draw a tree diagram because it's asking what are the possible outcomes of the series. So you have a first game winner, and then the second game winner, and then we'll look at all the outcomes at the end. So the first game winner might be the Knicks or Rockets or the Knicks. After the Rockets win, the second game might be the Rockets or the Knicks, or after in the first game, after the Knicks win, in the second game could be the Rockets win the Knicks. And then the possible outcomes would be Rockets win in 2 games, okay? And third game is required because the series is tied. If the Rockets win in the first game, then the Knicks win in the second game. Third game will be necessary. In the third outcome, the Knicks, if the Knicks win the first game and the Rockets win the second game, okay, a third game is also required. But if the Knicks win this first game and the Knicks win the second game, there would be no third game. The Knicks win in 2 games. Okay, so there are 4 possible outcomes. And letter B, the series can end in 2 games in 2 ways. The probability would be 2/4 or 1/2 because of these two. 1 and 2, that makes your 2/4. That makes it 0.5 right there. Okay? And the secret word for this particular lesson would be Denver. Secret word is Denver. And that's the end of our lesson. Thanks for watching.